looks like we're freaking live. Hello everyone and welcome to yet another recreational programming session with Aluzin. Let's make a little bit of announcement on our Discord server. And yeah, red circle live on Twitch. And what are we doing today on Twitch at .television website? Today we are parsing C. That's what we're doing today. I'm gonna give the link to twitch.tv/starting, and I'm gonna ping everyone who's interested in being pinged. I don't know how many people are interested in being pinged, but there you go. You guys are pinged now. It is inevitable. You are pinged. Hello everyone. Welcome. Really glad to see you all today. How are you guys doing? Welcome. So, you know, do you guys remember I used to program in Haskell? Do you guys remember? It was like a long time ago, but I used to program in Haskell. So, and Haskell has like this killer feature. Actually, it's freaking amazing. I used to use it all the time. So it's called Coogle. If you never heard about Coogle, I really recommend you to Google it. Just like literally Google the Coogle. And of course, DuckDuckGo is being the DuckDuckGo, right? So yeah, so okay, you can actually find that. So I'm gonna copy paste that in the chat for anyone who's interested, and of course I'm gonna put it in reference just in case. So this is Coogle. It's basically a Google for Haskell. So the cool thing is that you can just put signatures in there. Like, you don't know the name of the function, but you roughly know what function is doing, right? So you know that that particular function accepts other function that transforms A to B, and then it accepts a list of A's and returns you a list of B's. But I just don't know what that function calls. I kind of know the general shape of the function. So I put the type of this function in here, and what do I get? Oh, it's map, right? And there's also different kinds of maps, and it also actually matches these functions like very fuzzily, right? It does not necessarily like, you know, strictly matches this. So as you can see here, it accepts lists and return lists, but it also matched a thing that accepts functors and returns other functors, because lists are also functors, as you know, right? As any C developer knows that list is a functor, right? So every C developer knows that. Right, and essentially it just ranks it according to how close they are to the signature, and it is extremely convenient. Like, you won't freaking believe how, because like you just roughly know what kind of functions you need. Like, you know what it accepts, some of the things, you know what it returns. Like, why not just like sort by that? And that's what it does, right? So, and it's a great tool for exploring Haskell, right? Especially like if you just need something, you don't want to implement it yourself, you just ask the knowledge database, do you have already something like that? And quite often it does have that. So I want to have something like that for C, right? So for instance, like quite often actually, like I know roughly what I want from ArrayLib, for instance, right? So from ArrayLib, and I would go to ArrayLib and I would start searching for that thing, like by doing Control F, right? It would be kind of nice if I had some sort of interface where I would say, okay, so I need a function that accepts a caller and a float, and I know that the function returns a caller. So because I basically want to modify the alpha of the caller, and I want this entire system tell me, oh, okay, so you're probably looking for one of the functions that are called caller alpha, right? As you can see, it accepts the caller and accepts the float and returns the caller. On top of that, you probably meant maybe caller contrast. It also accepts the caller and a float, and you know, like basically one of those functions, right? So that would have been kind of convenient, right? So I want to have that. Like, you won't believe, like one of the things like Haskell developers did right is Coogle. Like, Coogle is freaking genius. Like, to these days, I cannot find like an equivalent thing in any of the language. Like, whatever comes with Rust is not even comparable to Coogle, right? Partly, Coogle is maybe possible because of how syntactically you describe the types of functions. Is just like very natural, right? It's super natural to describe things like that. For instance, like something like this is instantly const. It's just like very convenient. I don't know if it is possible to do something like that in C, but who knows, who knows, who knows. Right, so, and the first step in implementing something like Coogle for C would be to parse C. And apparently it is kind of an unsolved computer science problem, right? So there's some things, we could probably use libclang, but like anything related to clang and LLVM is an instant pain in the ass. Right, like every time I have to deal with like clang or LLVM, I like instantly feel that fucking pain. It's just like, don't want to deal with like any part of that project at all. Like I don't want to deal. It's just like overbloated, very complicated. Just so annoying. Right, so let me try to see. Like I want something like. Ideally, it would be kind of cool if it was like a C library, like a simple C library. So, for instance, Nothings has C lexer, which is like, you know, single header library, and it is a lexer. It's a self-contained freaking lexer, right? So yeah, you can find it in here, right? So I'm gonna put it in here. Why there's nothing like that but Parser? Maybe on top of that lexer as well. Like how complicated parsing C could be? Like how complicated could it be? Like I don't freaking know, right? So I want something simple. Like it doesn't have to be super complicated. It doesn't have to depend on too many things. It's just like simple, like this. Of course, nobody's gonna implement simple things because the people who implement simple things don't feel smart, right? To feel smart, you need overcomplicated, over-engineered solutions, the solutions that nobody except you can understand. Even you sometimes cannot understand it. If you can't understand your solution, that's good. You feel so fucking smart, right? It cannot be simple. It's just like cannot be simple. Otherwise, you're a failure. You failed as a computer scientist. You failed as a mathematician. You're a freaking failure. If it is easy to understand your work, it is easy to criticize it. And if it's easy to criticize, well, you're an instant failure. You're instant fucking failure. That's it. Your career is done. Fucking done. It cannot be simple. So somebody said interesting. So after lexing, isn't it basically parsed? No, because you need to build the tree, right? You need to make a sense out of the tokens. After lexing, you just have a sequence of tokens. You still don't have a general structure of the program. Lexing is definitely not enough. You need to parse it a little bit. Maybe you don't even need a parser that builds an AST. It could have been a parser in a sort of like a SAX style. Have you guys heard about SAX style parsers? Like for XML specifically. Right, so SAX parser. So let's take a look. I think I already mentioned them. Simple API for XML. So essentially, there is a DOM parsers for XML, and they build an AST. So you give them a string and they give you AST, you traverse the AST itself. SAX parsers actually go the other route. They don't build the DOM, they don't build the AST. What they do, they ask you, give me some callbacks. Right, give me a callback on when the tag is opened. Give me a callback when the tag is closed, and so on and so forth. And you give it a bunch of these callbacks, and it's just traversing the XML. And as soon as one of these events happen, the tag is open, or maybe an attribute is encountered and stuff like that, your callback is called. So if you want to build a DOM, you can do that within those callbacks. But if you want to just like traverse it and find a very specific place, and you don't really need a DOM, you don't have to build it. So I would be fine with a header-only C library that parses C in a SAX style. You know what I mean? In a SAX style. You know what's funny? This is how you interact with Jaya compiler. This is literally how you interact. Almost. So in Jai, there is a very interesting thing. So I wonder if I can find that. So let's actually go to Jai and maybe some examples. So there is a basic meta program, right? So basic meta program, and essentially you have a program, a build program, and within the build program you can start you can start the compilation process, and then you can organize an event loop, right? So essentially your event loop is running in parallel with the compilation process within the same process. You sort of inject some code in the compiler, and you have an event loop that is running along with the compiler. And essentially, the compiler sends you messages. It's like Erlang. Holy fucking shit. It's an actor model. Do you guys know about Erlang and actor models and shit like that? Erlang actor model? It is like that. It is like that, right? So you have two actors. Your building script is an actor, and the compiler is an actor. And as the compiler builds things, it sends you messages like Erlang. Holy fucking shit. And anyway, so, and you basically wait for the messages. Like there is literally a function compiler wait for messages. And then you have different messages like message kind, file, import, type checked. So the most interesting one is type checked. So that means some chunk of a code has been type checked, and you can do something on that. And there's a lot of things that can be type checked. For example, functions. So something like Coogle is actually very easy to implement for Jai. It is actually very easy to implement for Jai because it's going to be this meta program, this simple meta program that just waits for type-checked functions and collects the signatures of type-checked functions, and then you have the list of these type-checked functions and you just do the search on them. And then you can quite precisely give the locations within the source code on these functions. So something like that in Jai is actually freaking straightforward, right? So it would be kind of cool if there was a simple C parser that was like that, like Sax or like actor model. To be fair, this is basically like Sax, except given the callbacks directly, you do the switch case. But I mean, this is basically the bodies of the callback, right? You just move these things into the bodies of the callback, and there you go. You basically have the Sax things, right? Does it make sense? Does it make sense? Hopefully that makes sense. I don't freaking know. People are actually not saying anything anymore, right? The chat has stopped. I suppose I scared everyone away with all of this bullshit. Sex makes, well, I mean, sex makes not only sense, it makes a lot of different things. So we got some subs, by the way. Thank you so much, everyone who subscribed before, and Surprise, thank you so much for tier 1. You are the first subscriber of the stream. Congratulations, you are the first one who subscribed. Nobody else wanted to subscribe to me, right? Because I'm not really trustworthy. Why would you give money to me? Well, I mean, even if you subscribed, you won't give me money. You wrote a C preprocessor that works like that, enough to implement defer, for instance. Oh, that's actually pretty cool. Oh, that's really nice. So Pakel1 with the message first. I'm sorry, you're not first. You're second. First was Seprasi, so you're too late. You're too late, but I appreciate you anyway. I do appreciate you anyway. You get money from Twitch? Of course not. Why would I get any money from Twitch? Are you insane? Like, why? I can't sub, but I did recommend you on Reddit in the R Learning Programming sub. Someone was asking how to watch for advanced pro level program. Thank you for recommending me. In Russia we don't have any money. Yeah, because we have communism. It's like when you have communism, you don't have any money. So yeah. Anyway, so we need to find a way to parse C. Right, so let's actually try to Google some shit. So first of all, I would like to maybe right, put some you know, references in here. So we're talking about stbc lexa.h. So this is the lexa I was talking about. It is by nothings, right? So it is by nothing, and that's the implementation essentially. Right, so this is going to be something like that. This is Coogle. Also, we talked about simple API for XML, right? So for anyone who's interested, I'm also going to put that in the description just in case. Wikipedia, simple API for XML. So I'm pretty sure this kind of idea was not invented by XML, right? So basically having callbacks on some sort of like events. But this is, I keep bringing it up because in my career of software development, this is the first time I encountered this style of parsing. So that's why it's sort of like, you know, settled in my brain, right? So when I think about this style of parsing, this is the first thing that comes up to my brain because this is the first like time I encountered something like that. You may say that maybe my brain is permanently damaged by XML, but I mean, that's how people learn, right? So they remember the first thing they saw, right? So yeah, XML permanently damages your brain, so beware of that. And also Erlang actor models and stuff like that. You might be actually interested in this kind of stuff. So I wonder if the Google can actually give something interesting about that. So I would like to something from the official website. But anyway, so the idea of Erlang actor models is that essentially each actor is a separate. Okay, so we can give Wikipedia. I think Wikipedia actually explains this kind of stuff really well. Right, but I was saying that Jai uses actor model ironically, right? Because in reality it kind of works slightly differently. So don't don't quote me on saying that Jai has an actor model, okay? Don't quote me. Right, because John is gonna kick me out of the beta for saying things like that. So it was like kind of like ironically, because it kind of resembles that, right? So like you have actors that run in parallel or concurrently. Each actor has sort of like a mailbox and they communicate by sending messages to each other. So I just saw a message and I just made a joke. Oh, it's just like Erlang. So this kind of style. I'm not claiming that Jai has actor models and just like Erlang. I'm just making jokes, okay? And don't run around saying Zozin said Jai is an actor-based language just like Erlang. It was a joke. I know you. I've seen your comments on the internet. So don't do that. It's a joke. Right? Maybe my accent doesn't make it too obvious when I'm joking. I don't know. Jai is a paid actor. Yeah. All right. I already said enough bullshit on the internet to kick me out of Jai beta. So don't make the situation worse, please. So let me see. So let's actually try to Google something like C parser, and let's do that on Google. So there is a Python parser, pycparser, complete C99 parser in Python. I mean, do I have anything to lose in my life? I specifically have to do pip3. Okay, fail on me. On some wheel. Wait a second. Is that it? Really? Is that freaking simple? I was expecting that it's gonna just like download shit ton of third-party dependencies. One of the dependencies is gonna be native, and it's gonna fail with some sort of like wheel environment compilation error because I have some sort of a library that is not compatible with wheel type of version. You know, the usual thing that happens every time you try to install any Python package, right? It just fails with some sort of native dependency. Scripting language, by the way, cross-platform scripting language always fails on compiling native dependency, right? Like, look at that! Python is so fast, right? 90% of the Python libraries is written in C. It's so fast, the fastest language on the market. It's just like, yeah, it's C and C++. Okay, so let's do Python 3. Import pycparser. The fuck? Can I do help on pycparser? The fuck? CIST generator. Okay. Can I just do something like parse file? Okay, let's take a look at the help of this thing. So you but I don't really want to. Well, I do want to parse the file. Set to true if you want to execute a C preprocessor on the file prior to parsing it. Okay, so it does not do that. All right, so let's try to find some sort of a like array lib. I'm gonna go to the include, and let's try to parse these things specifically. Right, so we're gonna just take this pycparser parse file, and let's just give it a try. So this one has to be arraylib.h. Okay, so what does it say? Parser error. Before, maybe this is because it doesn't have a preprocessor. Like, I don't quite understand what the fuck is it saying. Parse error. It failed like straight up at 1.1. That's what's funny in here. That's what's funny with this kind of stuff. It doesn't even say, it's just like a parser error. Okay, so can we do use cpp true? GNU C VA list. Okay, so at least it failed at stdr. Okay, it tries to parse like literally everything. Can you handle preprocessor but don't include the files? That would have been actually perfect, to be fair. That would have been perfect. So, you know what? I'm gonna save this thing to some sort of like a file path, right? Well, I mean, not like a file path. Right, so here's the file path. So I probably want to move my camera a little bit here because we're gonna have a lot of things like around here. So is it okay if I'm gonna put my ugly face like at the right top corner? Is it okay? Is it not too inconvenient? I hope it is not. Okay, so we have a file path. Maybe I want to do from this thing import parse file, right? So now we have just parse file, right? So which is rather convenient, and I can always just do help parse file. So CPP paths use if use CPP is true, this is the path to CPP on your system. If no path is provided, it attempts to just, oh, it doesn't even do its own CPP scheiße. Okay, so it just like literally calls to an external one. So yeah, let's do parse file path. So what does it say? Yeah, of course you have to use CPP. And it doesn't even say. That is not particularly great parser because it just says before GNU VA list, whatever the fuck it means. Whatever the fuck it means. All right, so let me maybe go there, right? Let's actually literally go to this place and see if we can just find anything interesting in there, just like understand what exactly is going on here. Find file at here, and there we go. 40, so it doesn't like something like this. I wonder why it doesn't like something like this. Why is it something bad? So before GNU CVA list, because this looks like a normal type def situation, right? This looks like a normal type def situation, and why not just like allow that? So I don't really know. So if not GNU VA list, just define them and build in VA list. So do I really want to spend time on this kind of thing? Do I really want to spend on this kind of thing? So maybe this is too complicated. Maybe this is a too complicated of a file. But I mean, if it cannot parse that, like, why do I need this parser at all? I can try to do something super simple, but I mean, I'm not planning to parse simple things. I'm planning to parse real world source code. So if it cannot parse real-world source code, like why do I need this thing? It's just like, what? That's a waste of time, straight up. But we can try to do something. I don't freaking know. Right. So okay. So we're gonna do pycparser probe. I mean, yeah, simple. Let's call it simple. And this is gonna be main C. Right. So this is gonna be main C, and we can just do main like this. Very simple function. Nothing particularly special. So this one is going to be prop, parser simple, and Python 3. Maybe, you know, I'm going to create like main.py, right? Why didn't you open main.py? Thank you so much. Can you just enable Python mode, please? Emacs is broken. I need to restart it. Sometimes it gets broken. Sometimes it gets broken. Right, so user bin environment Python 3, and from pycparser parser import parse file, right? So, and we can just do parse file, maybe even print parse file main.c, something like that, right? So if it can parse this kind of thing, good, but this is not what I want to parse. I want to parse like a real world thing. Okay, it parsed something, cool. File AST, sure. So I'm gonna just go ahead and write a simple hello world. I'm writing a simple hello world like so. You cannot go simpler than this. You can't go simpler than this. And in here, we're gonna just say, okay, use CPP, and let's say a true. So, and if we run that, it's already failing. Directives are not supported. Well, I mean, wait a freaking second. Why? I said use CPP, didn't I? Because I'm an idiot. I'm a dummy dum-dum. Would you look at that? So we're supposed to put parentheses like this. And it fails like precisely in here. So just a simple hello world, already no. That is kind of sadge, isn't it? That is kind of sadge. I wonder why would it even fail like that? We can take a look at the actual implementation, right? So here's what's going on in here. Right, so it calls to pass error function when it fails to pass. Okay, so but before that, it called to that. So p error, if error recovery, okay, so it's all just reporting errors, right? So 2 frames in the call stack, everything related to just reporting errors, like Jesus fucking Christ. Okay, all of the such a long stack trace. It's just like all error reporting. Where is the actual thing happened? Okay. Error function, oh my god. Okay, parse OPT. Oh, right, this looks kind of interesting, sort of. LR parser, so is it just interpreting, you know, like yak or something or whatever? Okay, so C parser parse, I see. So that's what's going on basically. So that means it probably contains the yeah, okay, so it's basically generated yak stuff. It is just generated yak stuff from the grammar and whatnot. Maybe this is how they actually implemented that. Maybe this is how they actually implemented that. So thank you so much, Last Royal Raven, for 100 bits. Look into Tiny C compiler. If I remember correctly, that the last time I looked into Tiny CC or TCC, it was actually translating as it was parsing, if I'm not mistaken. Actually, I was looking into the preprocessor. The way preprocessor worked, it sort of fused with the Lexa. It is literally fused with the Lexa, and preprocessing and lexing was happening simultaneously. So because of that, I kind of assumed that, yeah, that this is how it works. But maybe parsing is actually a separate step, and you do have a separate like AST. Preprocessor is a black magic, and no, not really. We extended preprocessor at some point. at some point, essentially, we have a video on that. So I'm not sure if I can find that. Right, so let me quickly do that. Sorting TCC. We basically integrated curl into TCC. I wonder if I can find that, because yeah, there we go. So there is like a whole stream where we included C files over HTTPS. It was 2 years ago. It's such a fun stream. It's really underappreciated, right? It doesn't really have that many views, but I really recommend you to check it out. Like, it's such a fun stream. So essentially, we really extended the preprocessor of TCC. It detected that the path contains HTTPS, and instead of including it, it would call to curl and download it and then include it. It was so freaking fun. It worked. It fucking worked. And we didn't really call to curl as a separate process. We literally linked with the libcurl, right? We used like an actual libcurl. So I know a thing or two about internals of TCC. And one of the things that surprised me about preprocessor in TCC is that the preprocessor and lexer are fused together. So when you query, give me the next token in the preprocessor, it would first check if that token needs to be expanded by the preprocessor and then give you the next one. So it's not two separate steps, it's both of the steps simultaneously. And this is something that actually kind of confused me at first, and this is something interesting. And because of that, I think I kind of assumed that maybe it also compiles it like that. I don't know. So also let me actually put that thing in the description just in case. So where is the description? All right, so yeah, so this is Todding daily, and what's the title of this specific stream? Including C files over HTTP. Could you please you know, pause it? I'm trying to pause this thing. All right. Okay, that is absolutely poggers. So maybe it's worth actually looking into TCC. I think it's kind of interesting. Also, let me give the link to this thing. So this is pycparser, right? So pycparser, kind of weird. I don't know. Like, my verdict is that it works okay if you don't use preprocessor, but if you don't use preprocessor, do you even program in C? No. It's weird, a little bit weird. I do not understand that. Like, why? It has a lot of troubles, right, doing the preprocessor and stuff like that. So I don't know. I would give it 4 out of 10. I would give it 4 out of 10. So let me see. Tiny C compiler. Let's take a look at Tiny C compiler. What do we have? So as far as I know, Tiny C compiler, like, there is no like a central place that develops this thing anymore. The community of TCC is kind of like scattered across the internet. So there is like I think there was even several parallel development going on or something like that. So yeah, the current status as of December 2000, both official TCC mailing list and official Git repository show active discussion and development by main developers are interested. Announced. Okay, so it's kind of like a half dead. Right, it's a half dead thing. So let's take a look at the repo. Okay, so maybe we want to actually, you know, download that. Maybe I already have it somewhere. TCC. Okay, so let's do a clone. Let's do git clone, but let's do a shallow one. Right, let's do a shallow one because we don't want to. Right, you're saying this is not a thing. Okay. How do I clone this shit? Tree clone. Okay, here it is. Jesus Christ. These interfaces, I swear to God. just like a lot of irrelevant stuff on the screen. Like the only thing I care about is just clone it. Depth 1, there we go. Cool. So what is it called actually? It's called tiny cc. Very tiny cc. So do we have configure? We do have configure. Would you look at that? Holy fucking choice. Isn't that epic? Configure. So what kind of stuff do we have in here? So do I want to actually install it? We can try to install. So it does have a prefix. So that means, yeah, it's so by default it's user local and stuff like that. All right, so let's actually specify the prefix. The prefix that I like to specify is basically home, opt, and let's go tiny cc. All right, so we're going to install it there. That was quick. And let's just build it with 3 threads. Right. So we already have warnings. So it complains about formats. Who fucking uses printf like that? You don't put format string into a fucking variable. What the fuck is this shit? I'm disappointed. Like, I haven't even started looking into this. I'm already disappointed. Okay, so we've got some subs. Thank you so much, THDV. Thank you so much. I hope I pronounced your nickname correctly. Jewel, thank you so much for Twitch Prime. Thank you. All right, so what do we have in here? Okay, so it build. Would you look at that? Isn't that poggers? There's only one warning in here, actually. And what version is equal to? Right, it is version and then TCC version. And TCC version is equal to what? So I'm pretty sure maybe it is defined somewhere. Can we just grab our n, something like define? Will we find anything? Yeah, we do find that. Okay. All right, that makes sense. That's kind of weird, but it's not that weird. Right? It's not that weird. So let's do make install, and it should inject all of that into opt tiny cc. And if we take a look at here, there we go. We've got a fresh installation of tiny cc. That's how quick and simple it is. Right, can your clang do that? Can your clang compile and be installed that fucking quickly? I don't freaking think so. I ran out of team. So okay guys, so what do we have in here? So let me see. It's gonna be opt tiny cc bin and tcc. All right, so that seems to be working. We can try to do a simple hello world. Let's write a simple hello world. There we go, and we can just do something like this, and maybe void printf hello world. So then I'm gonna do, well, I mean, I already had it here, so let's do main.c, and it compiled something. Main.c, did it create a.out? Huh, I can't see choice. Okay, here it is a.out. Okay, so if I do a.out, it says hello world. We already have a working compiler. That's pretty cool. That's pretty cool. So we need to find where this entire thing starts executing. Right, so we need to find it. Maybe we can even debug it. So let's take a look at the executable. Right, so if I take this executable and just do file, does it have debug information? That's a very good question. Interpreted stripped. It doesn't have any debug information, unfortunately. You can't really see that, right? So let me actually put my ugly face a little bit more down. So there's no debug information, so it's kind of difficult to debug. So let me try to configure it maybe with debug information. So here is the prefix, but can we just add debug? Debug. Okay, include debug info with the resulting binaries. Isn't that cool? I think that's pretty freaking cool. Right, so configure, and then also debug. Boom. So does it mention debug? Yeah, it does mention debug, configuration debug. Let's build this entire thing. Let's also measure how much time it takes to build so we can mock clang. That's actually too fast. I can't believe that it's this fast. I can't really believe that it's this fast. So let's actually do -b, which will result in complete rebuilding of everything. So yeah, let's just dab on clang. Make command not. What the fuck is this make command not found? I don't know. So can your clang build in 10 seconds? Can your clang build in 10 seconds? I don't fucking think so. All right. So let's install this entire thing real quick. And also let's take a look at some other scheiße. All right. With debug info. We just got debug info on our compiler. That fucking easy. Okay, so now we can debug this piece of scheiße. Let's go to software, gf2, and I'm gonna do, let's actually literally go to opt, tiny cc, very tiny cc, and just that, but let's run it in a separate thread so it doesn't block anything. And I'm pretty sure the entry point to the compiler is literally called main, so that means if I do break main, it will create a breakpoint, and as you can see, it created a breakpoint, so that means we can instantly find where is the entry point. That's actually a very interesting technique. That's such a very cool technique of finding entry point of a program. Just open it in a debugger and do break main. Right. And the debugger will tell, okay, so here is the main, this is where it's located. In fact, you can find any function in there, right? So for instance, you want to find TCC set option, right? So you break on TCC set options, right? And then you go to that, there we go, we just found it. So who needs IDEs if you have a debugger? You can pull out this information straight out of the debugger. Haha! Anyway, so let's actually do run a main. Boom. Okay, so we are running the compiler in the debugger. How cool is that? We're running an actual C compiler in the debugger, and we're looking how this motherfucker works. So one of the things we can take a look at what kind of arguments do we have in there. So first argument in here, as you can see, is the path to the compiler. It is not particularly interesting, so the second interesting thing is probably here, and it is the path to the file that we're trying to compile. So we do have this entire stuff. All right, so let's actually start stepping. Right, so there is a redo, so it's using go-to to try parse things again. One of the things we do in here, we create some sort of like a TCC instance or whatnot. That's very interesting. So let's actually take a look. So it's S, it is optimized out for whatever freaking reason, but there's also S1. All of them are optimized out. I wonder if with step, they're not optimized out anymore, and they're both point at the same thing. So I suppose this is just the instance of the, the instance of the compiler. So it just like contains the state and stuff like that. This is actually kind of cool. It contains a lot of interesting shit in here, as you can see. So GNU extensions, TCC extensions, include sysdeps, do debug, do bench, warning errors, warning all, and stuff like we have everything in here. So that's the state of the debugger. And next thing we do, we're trying to parse the options. Like, I wonder what the fuck is an option, right? So if we take a look, it's not materialized yet. Let's actually take a look at that. So OPT is, I suppose, basically the result, right? So if it's less than 0, that means there was some errors. And since it accepts S, the state of the compiler, it probably parsed all of that information in there. Right, so some of the things are initialized with this kind of stuff. So if I were to provide, for example, WAll, this particular thing, warning all, would have been set in a structure. That's actually very interesting. So let's actually try to do that. So here is the beginning, and here's the next one. So I'm going to do delete, and let's actually kill the compiler, right? So I'm killing it, and I'm running it with main.c, but I'm also running it with WAll. Right, and as you can see, warning all are set to 1. So, debugger is actually a very powerful tool for exploring the programs, isn't it? I think it is. I think it's pretty freaking cool. Right, so you can just like go ahead and explore it. All right, and I wonder if some way here we have maybe AST. So we can just go down a little bit. So there is parsers and stuff like that. So let's actually just step forward a little bit. So N, we have some sort of an N thingy. I'm not quite sure why we have S and S1. It's kind of weird. So N is 0, so that means this entire chunk of parsing different things is going to be actually skipped, so we don't care about that. No, well, I mean, it is 0. All right. All right, OPT is 0, OPT help. I suppose majority of these things are going to be skipped. I don't know what the fuck it is. All right, so this is like additional thing. NB files. And I suppose NB files is the amount of files that we have to process in NB library pass. I don't know why it is called NB though. I don't know how it's called NB. So I suppose what we're interested in is some sort of a parsing step. Some sort of a parsing step. Set environment. This one is interesting. Okay, let's skip it. The output is gonna set output txt. Output type, so it sets the output type. So output memory, preprocessor, probably none of that. Compile or add each files to the library. All right, so we're starting to iterate through the files. So maybe we're interested in things like F, right? So we are basically iterating through the files in here, right? So we have all of the files. And that's the first file we're trying to handle, right? So it starts with M, I suppose it's just basically main C. Right, so, all right, so it's not verbose, it's not the first file. TCC, okay, TCC add file. This is interesting. I think that's a function that we're interested in, TCC add file. So let's actually step in. Okay, so, S has a type TCC state. And there is a function called TCC add file, which probably does the processing and stuff like that. This is actually super cool. All right, so there's a file type and we're just dispatching and different types. So we're not really interested in any of that stuff anymore. So extension, so we're extracting the extension. We figured out that the extension of the file is .c, right? And now we can take a look. So it tries to figure out what's the extension. So it looks whether it's extension S for assembly, right? But we have extension C, right? So we have extension C, so it's probably gonna stop at here somewhere. So it detected that, okay. So TCC add file internal. All right, so there's one layer of indirection. So it figured out the type of the file and then it does something with that. Okay, so let's actually step into that one more time. So this is an internal thing. It's just like, yeah, so you just add a file type. Okay, TCC output preprocess, ignore binary, blah, blah, blah. So this is some sort of like hex. Open file. All right, so we're opening the file. We're opening the file. So by the way, people keep asking about the debugger, right? So the debugger, what I'm using is actually front end for GDB. So the debugger I use is GDB. And on top of it, there is a front end, which is called GF. You can find the source code for this thing in here, right? And for people who potentially, maybe, I don't really know, watch on YouTube, this is going to be here, right? So it's a next. GF2, and it is available in here. It is actually super simple, and you can build it with just like one, command line, right? So you don't really need to install it from third-party dependencies or anything like that. Just download it and build it on your machine, right? Just download it and build it on your machine. So what is FD? FD is optimized out, so we don't really know what it is. So it's like file descriptor. It returns the file descriptor. So it opens successfully and flags if type bin. So din array add. This is the holy grail of this scheiße. TCC compile. Look at that function. Yes. Step in. TCC compile. Okay, so there is a message in here for us. The developers left a message for us. Unfortunately, GF doesn't let. Okay, so GF actually allows us to read that. Compile the file opened in file. Return non-zero if errors. Okay, so here we enter the code section where we use the global variable for parsing and code generation, tccpp, tccppc, tccgenc, and target gen c. Other threads need to wait until we're done. Okay, so it's multi-threaded, holy fuck. So alternatively, we could use thread local storage for those global variables, which may or may not advance. Okay, so there's nothing interesting in here. Okay, so where do we start set jump? Do you guys know what is a set jump? Do you guys know what is a set jump? Ooh, it's a long jump. It's like, imagine goto that can jump between the functions. Yep. So it's so-called the long jump, right? So it's a long jump. I think Wikipedia article, maybe like a CPP reference is actually a good explanation on this thing. Loads the okay, so long jump loads the execution context environment saved by a previous call set jump. So goto usually accepts a label where you should jump. Set jump doesn't really set any label or anything like that. It saves the execution environment, whatever that means. And whatever that means depends on the platform you're currently running. So it saves the current execution environment. And then when you perform the long jump, when you give that environment to long jump restores the environment saved by set jump. Like, what the fuck does it even mean? It makes sense kind of to me on a level of assembly. So if we say that environment is the state of all of the registers and the stack, right? We can save the state of all of the registers and the stack, and then we can restore it. So that way we'll restore where the stack is currently located, where the execution instruction pointer is located, and the environment variables and stuff like that. It will kind of restore where we did the set jump. And the reason why people use that is to kind of emulate exceptions in C. So essentially you can remember the environment before doing a very deep, complicated parsing compilation process. And when something wrong happens very, very deep in the call stack, you want to quickly unwind that and get back to the beginning so you can report an error. So that's what long jumps are usually used for, right? So before doing very complicated, deep recursive thing, you just, okay, I'm saving my current environment and I give that environment to the process that was going to do complicated things. And if something bad happens, it allows the process quickly restore that environment back to the beginning so it can report things. It is like a snapshot, right? So essentially people like a snapshot. Yeah, it is like a snapshot. It makes sense on a level of assembly, because in assembly, this is literally something that you can do technically. You can just take the state of all of the registers and just save them and then restore them, and you get the same effect effectively, right? But since C and C++ is supposed to be cross-platform, the environment may mean different thing on different platforms. Right, so is that a good explanation, right? Because it's kind of difficult to explain. Goto is easy to explain, but long jump and set jumps is difficult to explain because they make sense only on a very low level, on a level below C, right? So it's kind of like it's a feature that is kind of out of place, right? So it's on a wrong level of abstraction, right? Because to actually implement something like this, like you cannot implement it in C. You cannot implement this function in C. You can only implement it in assembly and only for very specific platform where it is even possible at all. Maybe there is a platform where it is impossible to do set jumps and long jumps or stuff like that. Like, can you do long jumps in WASM? I don't think, like, that's a good question. How to do long jump in WASM? Because WASM is actually so kind of like isolated and so like fortified. You can't even get an access to like a memory where the instructions are located. So it's like a memory that is not accessible to, like, maybe it is possible somehow, but I don't think so. This is a very good question, actually. Long jump WASM. How would some, yeah, so people actually, that's a very interesting question. So I started looking into WASM and noticed that there is no access to the stack and stack pointer, or indeed any structured exception handling support. Given it is supposed to be C compilation target, it surely must be possible to implement set jump and long jump. But I can't fathom how this can be done nicely. How does this construct look in WASM? Zero cost execution handling isn't supported. What the fuck is a zero cost? Zero cost exception handling. In MVP, I don't know what that means. Exception handling are currently implemented through mscripting by having each try or invoke perform a call to JavaScript with the continuation to WASM WebAssembly C++ code. Oh my god! But it's only like try. Yeah, okay, that is. So basically, in WASM, it's a huge pain in the ass. Right, in WASM, it's a huge pain in the ass. Like continuation, it's just like similar to how I was implementing GoTo for Camel or something like that. So anyway, let me actually give the link to this kind of thing. So this is a CPP reference long GMP. All right, so essentially we're saving an environment right before trying to do something very complicated, right? And we're saving the environment within the state of the compiler, right? So the state of the compiler apparently has that environment in error jump buffer. So S1 error jump buffer, right? So this is where it's okay. That's very interesting. So this is how it is implemented on my machine, by the way. So there's a jump buffer that consists of 8 bytes, or maybe eight elements or something like that, right? And so also saved mask or something like that. So it's just like basically data. It's really interesting. Like, what's gonna happen when you? Okay, so I suppose this is basically the state of the registers, right? So, and the specific structure of this thing, I suppose, will be different depending on the platform, right? So on my machine, it looks like this. And yeah, that kind of looks believable, right? That kind of looks believable. That could be like the state of my registers and stuff like that. So, and maybe the stack pointer and whatnot. So yeah, I wouldn't be surprised if it is like actually true. Anyway, so let's continue. So TCC open buffer, we're opening the buffer. Okay, so this one is interesting. Preprocessor start. So we're starting the preprocessor, whatever that means. Okay, so TCC gen, TCC preprocess, begin file. Not really sure what that means. So TCC gen compile. So let's go into the TCC gen compile. So what do we have? Do we have already the AST? So I want to find the moment when we are going to have AST. So we're starting something. Okay, parse flags. This is interesting. So we're parsing flags. So there's a function called next, whatever that's supposed to fucking mean. All right, so let's continue with this kind of stuff. I have a feeling that I literally missed. Yeah, elf end file. I literally missed the moment where it happened. So I probably should have went into a function called next, right? So where is next? Okay, here is next. Return next token with macro substitution. That's really weird, but anyway. So exit. Okay, let's continue execution. Maybe we're gonna find something interesting. So then we're returning out of that. So we process the file, do bench, run tests, output preprocessor. So maybe we already have something useful within S1. Do we have the ASTs or something like that? I don't think so, actually. TCC output file, TCC print, TCC delete, and done, and we're basically done with execution. I didn't catch the moment where we started to parse anything, to be fair. Do we even parse anything anywhere? Like, I couldn't catch it. Did you guys catch it? Like, I don't know. I couldn't find it. So let me try to do CCC. What was that? Tiny CC. So is there maybe some file name that contain word parse in them? There's no such thing. Okay, we can grab parse just to see. Okay, so there's some stuff in here for parsing. TCC-pp. So it's primarily in TCC-pp, which is a preprocessor and stuff like that. So there's a parse define. Parse define, but this is preprocessor specifically. I don't think it's particularly useful. Parse asm TCC gen. I have a strange feeling that it literally, you know, just parses and generates stuff simultaneously, just like an old style C compiler. So like an old style C compiler. The most like reliable thing would have been maybe to use libclang, but I don't want to deal with libclang, honestly. I really don't want to deal with libclang. Something like in Jai would have been cool. Wait a second. Chat. Libclang. Jai. There is, for people who are in a Jai beta probably know what I'm talking about. In Jai, in a standard library of Jai, there is bindings generator. And you know what it does? It uses libclang to generate C bindings for Jai. To generate C bindings for Jai, it needs to parse C and have AST and traverse AST and probably do this kind of stuff. Can we use Jai to parse C? What the fuck? I never used this bindings generator, but people told me that it works really well. People told me that it works really well, and they use it for their libraries, for their projects and stuff like that. And what's cool is that it should have precompiled, yeah, it already have precompiled libclang binaries like SOs and libs and stuff like that. So they already dealt with all of the libclang bullshitry. So here is the binaries that you can just use. Right, it has some of the headers and stuff like that. So maybe we can use that. What the fuck? Isn't that poggers? Meine Freunde, isn't that poggers? Okay, so thank you so much, Mazarona, for tier 1 subscription, and Anonym Z, thank you so much for Twitch Prime. Thank you. Really appreciate giving money to Jeffrey Bezos. All right, so let's give it a try. So this is something interesting. Examples. Okay, so usually in Jai there is a convention. All right, there is a convention that the thing that you need to compile the whole project is the file first.jai. And this is probably where we have to start exploring everything. So this is the first thing that we have to compile. This is a small example of compiling a CPP library, generating bindings for it and using them. Look at modules imgui generate.jai or module direct3d generate.jai for more comprehensive examples of how to use the bindings generator. So I suppose they're generating bindings for cpplibrary.h and cpplibrary.cpp. All right, so holy fucking shit, that's like a straight up CPP with like inheritance and virtual functions. So Jai can interface with this shit apparently. Can your Rust interface with C++ with virtual functions and shit? I genuinely don't know. I don't know the state of Rust. Can it? Like, I don't freaking know. So probably using CXX. I don't know what is CXX. It's some sort of like a library for Rust. Because that's actually kind of cool, right? Because like it's using like C++ specific bullshit, like you know, virtual tables and stuff like that. It sounds kind of difficult to interface with this thing. That's why nobody does, right? C++ essentially implemented all of these epic features, and because of these epic features, nobody wants to interface with C++, and everyone is trying to interface with C. And every time you want to interface with C++, you write C wrappers around C++ code so you can just interface with that C++ bullshit. So that's literally what people do, right? Okay, so we have... Anyway, whatever. So this is basically a Windows new line, right? So it's a Windows new line. Only one single one in here, and everything else is actually Unix new lines. All right. So, and here is the CPP implementation, and this is what we're doing in here and stuff like that. Okay. So what we're doing in here, we're doing build CPP dynamic library. So that's what we're doing in here. And as far as I know, this is just like a standard build thing in Jai, right? So you can just give it like this thing and it will build it on your platform. All right, so then we're building main.jai. Okay, so this is C++ code, right? So this is C++ code, and main.jai is a Jai code. Okay, this is very interesting. Wow. Okay. So that's how you use virtual methods, right? So you have to explicitly call constructor. You have to explicitly call destructor, but since you have a defer feature, it's actually very easy to do, right? So defer acts like destructors and stuff like that. That's kind of cool, right? And then you call directly virtual method. So what's the name of that method? It's called it's just called virtual method. Okay, so I thought virtual in the name came from the virtual keyword, but apparently it did not. Right, and here, if it's Windows, we have to do one way. Right, and also there is platform-specific things for each individual thing in here. Right, so there's a linux.jai, and I suppose this is the generated... Oh, I see what is going on in here. Yeah, depending on the platform, the methods of C++ are going to be mangled differently. Ooh, yeah, and on Mac OS, well, Mac OS, they're kind of similar, but I suppose on Windows, yeah, as you can see, their names are kind of like. Do you guys know what the fuck am I talking about? Even? Right? Do you guys know what the fuck am I talking about? So if you have, like, I already demonstrated that like multiple times, but I can do that one more time. So let's create a C, actually not C++, but C program. Maybe even something like foo-c. Let's create a function foo, and yeah, that's it. Let's just a function foo, just a function foo, and let's just compile that thing as an object file, not as a final thing, but as an object file. Right. So we have foo o, and there is a utility in Linux that basically allows you to look into the names, and there you go. It basically says that there is a function foo in that object file, and basically it gets that information directly from this binary object file, and the name of the function is still preserved within the object file. It is very important for the linker. Linker then looks for these names in object files and basically connects different object files together. So it knows that that object file calls to that function with that name, and that object file contains this function with that name, so it knows how to connect those things together. So it's very important to preserve the names. The names are not lost after the compilation, they are still available in the object files. Right. So, and if you have a function foo, there will be a foo symbol in the object file. Now, let's rename this thing to CPP. I'm renaming it to CPP, and I'm going to try to compile this entire thing as a CPP using CPP compiler. Right. So now I'm going to take a look at the names. And what the fuck is this name? So with C, if you had a function foo, you would get a symbol foo in object file. In C++, you will get this monstrosity. What the fuck is going on? Why the fuck? Like, how? And by the way, this make the C++ program incompatible with C. So they're not linkable because of that. You have to do a special extern C. I think, like, if you could just do extern C, only then the C++ will basically use the C names. Yeah, there we go. So you have to explicitly say extern C to actually not do that. What the fuck is going on? So in C++, this is called mangling. It mangles the names. It mangles the names. And why the fuck do you need mangling? Well, you need them to distinguish between this function and this function, because C++ supports overloading of the functions, right? So essentially, depending on the arguments that you provide to this function, is going to call either to that or to that, right? So, and essentially, the only way to distinguish between those functions is, like, at least on the level of the object file, is by their name. And in fact, mangling encodes the signature of the function, right? So, for example, the one that accepts integer has the letter I in its name. And as far as I know, like, it's sort of like a semi-standardized. The way the names are mangled as semi-standardized, but depending on different platforms, they could be kind of slightly different. They could be kind of slightly different. And this is exactly why we need to have separate files in Jai for separate platforms, because on Linux it is mangled like that. On Windows, it is mangled like that. So Windows like to use this kind of shit. I mean, Microsoft Visual Studio compiler, right? And in here, for Clang and GCC, we mangled them like this. C++ was such a great idea. Holy fucking shit. Oh my god. Zero cost abstractions. Having overloaded functions literally costs nothing. Actually, it's actually a very useful feature, to be fair. But anyway, so... Isn't that great? It is absolutely fucking great. Right. Abstractions, they come for free. You pay nothing for them. Okay, go. So that's basically what's going on in here, right? Depending on this kind of stuff. Right. It is what it is, and it isn't what it isn't. Okay, go. Okay, go. So we compile main.g and we just do that. All right, so, but there's also this function called generate bindings. Is it called during the, okay. Right, so before trying to compile anything, we call generate bindings, and if we couldn't generate bindings, we just say, okay, couldn't generate bindings, whatever. So how do we generate bindings? We look, so generate binding options, so we have to set up some options and stuff like that. We look at the current platform. If it's Windows, we just do Windows. Right, so all these things like Windows Jai, Linux Jai, and macOS Jai are generated by the generator and stuff like that. And we just basically construct the command line arguments for these things. So here's the libraries, system paths and stuff like that. So source files, we just like add all of that together, and we just call the final function called generate bindings. And it's supposed to do the magic given all of that. That is pretty straightforward, not gonna lie. So I suppose the entry point into the generator, into the bindings generator, is this generate bindings function. Okay, that looks pretty straightforward. Let's go ahead and try to just call Jai Linux first.jai. So what do we have in here? So we're waiting, it's doing things. Okay, so it's building our library. Okay, so stripping inline function constructor, that's very interesting. I don't know why it pointed it here, but whatever. Generating 87 global scope members, 31 functions, 4 structures, and zero enumerations. Okay, generated linux.jai. That is absolutely poggers. It just worked correctly. it just worked correctly. Absolutely insane. So, and it also created SO. Not bad. Not bad at all. So, and then I suppose it should have generated, okay, so here is an executable example. And if we try to run this executable example, we'll supposed to, okay, all right, so we just see the trace log of creating classes and calling virtual methods and stuff like that. So it actually works, right? It actually works. So we can clearly see that. So that's pretty cool. So, but we don't really need to interface with this kind of shit. What we need is to parse C code, take its AST, and traverse it and maybe search for stuff like that. And how this kind of thing can be useful for us? Well, we can literally look into the source code of generate bindings. So because to generate bindings, you need to parse C and C++. You can't generate bindings if you didn't parse C and C++. By definition. Can you? Magically? I don't fucking think so. You need to parse it somehow. You need to have you need to have A, S, and T. Very importantly. A, S, and T. So let's explore how this mother flipper does that. Let's explore that. So we're gonna go and like literally grab it and find the definition of this thing. All right, we found at least 3 examples of that. So, all right, so there is a generate bindings, and then inside of the generate bindings, there is another one. So as you can see, Jai also supports overloaded functions. So that's why I said that even though you have to pay a little bit for that, the cost may be worth it. The cost actually may be worth it. So interestingly, Jai also does a version of mangling, and rather interesting one. So it actually adds like a number suffix to the file. It's kind of a little bit weird. So I wonder if we can see that. If I take a look at the names in example, I think we'll be able to see them. Yeah, this is the mangling version of Jai. So it preserves the name of the function and it adds this like sort of unique identifier like a hex. I don't really know how exactly mangling in Jai works, and maybe it's not even called mangling. Maybe the word mangling actually offends John because he hates C++. Maybe it's not even called mangling. And maybe I just got kicked out of beta for even calling that mangling because I'm an ignorant idiot who doesn't understand how this entire shit works. So I should be really careful by saying this is mangling. So it's probably not. Right, because C++ sucks, John hates C++, this is not mangling. I don't know, right? I don't really know, I'm really scared. I'm constantly scared of being kicked out of beta, right? For saying something stupid, because I say stupid shit all the time. So, anyway, so I'm joking, by the way, so John doesn't really do this kind of stuff, so John is actually very cool. Anyway, so yeah. Let me take a look. So I suppose the actual generation is happening somewhere here. Generate bindings. Okay, so there's another one, generate bindings, that accepts the logs and stuff like that. So maybe we want to go in here. And the first thing we want to do, clang dispose tokens. Set allocators. New context generators, generator option lib names. What the fuck all of that means? I have no idea. Clang create index, clang dispose in. We just only started to read this entire shit and already going fucking crazy. What the fuck is all of that? Clang. What the hell is wrong with you? Anyway. Oh, look at that. There is literally a function called clang parse translation unit 2. Oh my god, this is such a bad code. This is such a bad code. There is a function with the name, with the word 2 in it. I mean, with the number 2 in it. It needs to be refactored immediately. It's unreadable. It's impossible to read. Oh my god, such a bad code. Anyway, people know who I'm talking about. Anyway. I'm actually kind of surprised that there is a function literally called parse translation unit too, like just parse translation unit, because that's literally what we want. I wonder if we can try to find this kind of thing somewhere. Okay, so you know what? Isn't that like literally? Wait a freaking second. This is literally from Clang, libclang. This is literally from libclang. This is literally from libclang. Wait a second. Are you that guy from comment section on YouTube saying that Clang developers are bad developers? How dare you say that? Did you just insult the gods themselves, the creators of the compiler that you use? You trying to imply that the Clang developers don't know what the fuck they're doing? They created function with the 2 in the name. What the fuck? This is absolutely... You dare to say, you dare to doubt the gods of the compiler development. How dare you? So, like, they have a function too. Because Clang parse translation unit was so good that they made a sequel. Obviously. That's how you improve your code. If the first version of your function was good, you make a sequel, right? That's how it works. That's how it fucking works. Anyway, so that's actually kind of cool. So maybe this is literally what we can use in here. I wonder, though. I wonder. So it's literally from this kind of stuff. So we have to supply a lot of things before we can even parse and stuff like that. So full args. And there's only one place where we do that. We count translation unit. So this is the translation unit. So there's a CX translation unit. And I suppose, right, CX translation unit implementation. So, all right, that sounds like a good place to start. Sounds like a very good place to start. Yeah. How can we utilize that? How can we utilize that? I'm thinking that we can essentially try to just extract that code out of the bindings generator and try to like make a local version that just parses a particular file and tries to traverse that file and stuff like that. So that should be good, I think. That should be good. So context generator option, generate library declarations. All right. So, but before we do that, I think I need to make a small break because I've been exploring different possibilities, the possibility space of different parsers for 1.5 hours. So I ran out of my tea. So there's no T in IST anymore. So I need to make some tea. So yeah, let's make a small break. And after the break, we're going to try to explore how to just like yoink some of the code out of this library. So, all right. So let's see if we can strip off Clang from this thing, right? I wonder if we can. So the way you're supposed to use that, I think, right. So there is a generate.jai. This file generates the bindings for libclang, which is used by the bindings generator itself. Oh, this is so fun. Right. This is actually pretty cool, right? You need to generate bindings for bindings generator, right? So there is like a types to emit and everything. That's actually super cool. So it's a self-hosted bindings generator. So in here, we're probably doing some imports. Yeah, we're importing bindings generator, but by importing bindings generator, I wonder if I can use the Clang things. I wonder if I can. This is actually a very interesting question. So if I do Clang parse translation unit. So where is it available? Like one more time, I'm gonna, like I already had it in here. So it is available in Unix and stuff like that. Right, so parse translation unit, and it is kind of public, so there's no scope in here, right? So there's no scoping. So there's a scope file, right? But it's like the only internal thing is the libclang library itself. So that means that maybe theoretically, by just using the bindings generator, I also will have an access to all of these things like clang parse translation unit. Right. So that's hypothesis. That's at least hypothesis. So let me now go and maybe create, let's literally create a folder for the project, right? So Coogle, right? So we're gonna call it like a C, Coogle or Coogle or whatever. And let's create main.jai. So we're starting to code in Jai. Right, so we keep switching the languages. First we started with Python, then we did C, and now we're doing Jai. Welcome to Coding channel, right? So that's why I'm telling you, don't learn languages, learn programming, so you don't depend on specific languages. It's kind of like a weird thing to say, because the way you learn programming is by learning different languages, right? Because programming is a universal knowledge on the intersection of different technologies and languages. So to actually learn this universal knowledge, you need to learn several languages and several technologies to see that intersection, right? So, but the reason why I say don't learn languages, learn programming is that you focus, you understand your goal. Right, when you learn in several languages, you understand that you're not just learning and memorizing several languages, you're looking for that intersection between the languages to like acquire this like intrinsic knowledge of programming that is universal across all of the languages. And the programming actually universal across not only like imperative languages, you may say, but what about Haskell? If I learn several imperative languages, I won't be able to learn Haskell. Learn Haskell as well, and you will learn the common things between C and Haskell. Actually, there is a lot of common things that are applicable both in C and in Haskell. You won't believe how many of them, especially if you consider the fact that if you need to write anything useful in Haskell, you will have to reinvent imperative language in Haskell anyway. So, yeah. But that only makes sense if you really want to learn programming, right? If you want to just like quickly, you know, make some money on a trendy language, I guess like good for you, go ahead, learn some JavaScript or whatever, right? But then when the industry changes very, very quickly and you won't be able to adapt, well, that's because you will learn the wrong thing. Instead of learning programming, you will learn JavaScript. Because if you know programming, you become immune to these turbulent things in the industry, right? Because the popular language has changed, but you don't have to learn new language. You already know programming. You just like, look, okay, the popular language right now is this one. Like, okay, I just learned it within a week or so because I know programming. So I know, like I would like look to how to do the things that I already know, but in that language instead of learning the language, right? Anyways, right, so let's do hello world as usual. So hello world. And let's do import basic. There we go. So Jai Linux main.jai. So what do we have? And we've got something. Everything seems to be compiling, and we've got a hello world in Jai. I'm sorry. In Jai, you're supposed to say hello Seaman. That's the traditional hello world in Jai, right? So you're supposed to say hello Seaman. There we go. So that's how we're supposed to do that. Okay, so let's do import and bindings generator. So and see if this entire thing compiles. It does in fact compile. And the real question is now, can I do clang parse translation unit? So if I just provide 69 in here, will that work? Okay, so it's saying something. Okay, not enough arguments, wanted 7 but got 1. This is, I see this as an absolute win. Because, for example, if I called a function that didn't exist, let's actually do foo. It would say undeclared identifier foo. Right, it would just say undeclared identifier foo. But we called function that did exist. So it complained that we didn't supply enough arguments. So that means we already have the clang bindings without copy pasting anything like that. That is perfect, right? So, but where do we get all of this shit? Honestly, I don't know. So let's take a look at the you know, the bindings generator. So we have to provide. So we can try to do this kind of thing. So we're gonna copy paste this entire stuff to main. And let's just steadily get all of these things in here. I would like to even have maybe a signature of this thing, right? Can we have a signature of this thing? I think we should be able to have a signature somewhere. Right. So here is the signature. And I'm going to put that in the main function in here so we can see what is going on. It would be nice to maybe like have this as separate sort of names. Unfortunately, something is really wrong with gmod in Emacs. Right. Okay. So we need these kind of things. We need this kind of thing. So source file and stuff like that. Module. So index. Where do we have an index? Clang create index. So that's actually kind of interesting. All right. So let's go ahead and create index. Might as well comment this thing out and maybe print that index in here just to see what it is. Okay, so here is the index, and let's just go ahead and compile this thing. It in fact compiled. We can actually compile and run it simultaneously. All right, so we cannot load shared object file, no such file or directory. So we can't really see that. So let me actually, yeah, there we go. So it can't find libclang.so. We tried to call to this thing, but we couldn't find it. So that is very interesting. So people also say that I actually missed the defer, right? So defer is actually quite important because we are using like array AI here, RAII. Right? So that's why we have to have that. So we just don't have you know, SO in here, and this is something that we probably have to steal maybe from somewhere. So let me see. I wonder if I. Yeah, that's kind of interesting because why can't I just do that? Why can't I just do that? Because, for example, in example here, it works, but maybe because it's actually sort of like abstracted away. We can simply do that. LD library path, and just put it like this. And it still didn't work, maybe because the environment variable is applied to a wrong. Oh yeah, I should remove the ampersands. So it is applied to the wrong command. It should be applied when I run this entire thing. It still didn't work. That is very surprising to me. So let me take a look at LDD. So it's looking for libclang so.16, and I'm pretty sure if I go here, there will be that thing in there. Right, so just a second. Find file at point. Oof. This is actually not true. Right, so this is not SO. So it looks specifically for that .16. That is very interesting. So do we have any other files that contain libclang? No, that's the only one. But why it looks specifically for libclang 16. Okay, libclang.so. Who's referring to that? Nobody's even referring to this thing. Oh, I think I know who's referring to that. Okay, okay. So it's looking for library, right? And I suppose, yeah. Is there any way to do our path? Is there any way to do our path? It's a so name mechanism. Yeah. It's a so name mechanism. One of the things we can try to do is maybe make symlink to this thing, right? So we can try to do that. But Emacs is sometimes slow. Let me try to just do main, right? And essentially, we can go to, but can we just link it in here? Right, so ln, so what's the order of the argument? So the target is here, all right, so that means I can do ln s, so symbolic link, opt, j, it doesn't want to auto-commit, modules, bindings generator, bin, libclang so, and just do it libclang so.16. All right, so we have this thing locally that points to that thing there somewhere. Right, and if I try to do main, there we go. It created an index and it said hello Simon. It's kind of a weird way to do that, right? So, but yeah, so maybe it's fine for now, right? We just want to make it to work somehow at least. We just want to make it to work somehow at least. And we managed to create an index, and now we can try to work on the rest of the things. So here we have to provide the source. The first thing we have to do, we have to provide the source file name, which is rather interesting. So here we do not provide the source file name, so we put null in here. So this one is weird. So maybe this is not the place where we have to do that. A clang parse, yeah. So maybe we have to do that in several places. So this is the only place, but maybe it is basically done somewhere in the argument. So argv, where do we have argv? Where do we have argv? So we have do debug, and do debug is probably a parameter of the module. Yeah, is it parameter of the module? It's not actually a parameter of the module. It's like a global thing. We can enable it. Right, and let me go into the examples and try to build the example that we have in here one more time. First.j. So it is printing command line arguments. So this is the arguments, and they do contain. Okay, so here is a temp file content include cpp library. And then I wonder, what is the generate temp? That is very interesting. So it's basically generating temporary file which just includes the library that you want to include, and it just supplies that thing as a command line argument. Okay, that's very interesting. So there's also include in here and stuff like that. Seriously, you are passing Win32 lean and mean on Linux. That is silly, goofy ass arguments. Like, come on. I mean, it's gonna work. It doesn't break anything, but it's just silly. Right. So there's no dispatching there somewhere on the level of, like, if you're on Linux, just don't pass it in there. It's not stupid if it works. Yeah, I do agree with that. It's just like that. That's why I didn't say it's stupid. It's just goofy and silly, but it's not stupid. Like, I can see why it works, because it doesn't really matter on Linux. You can just enable it. It's fine. It's kind of funny. So let me see some stuff. Module. So how is it created? Parse translation module. So this is where we create. Okay, so this is the temporary file, and we're just including this entire thing. Makes sense to me. Does in fact make sense to me. So that means we just don't use the second argument to supply the source code. We use the command line arguments to supply the source code. That's what we do. And the arguments that we supply is this, right? This one is actually rather interesting. Maybe we can use them as well. Maybe we can use them as well. Let me see how we do the argv. So we can just generate them. Assemble an array of C strings arguments for clang. So there's also temporary files and stuff like that. So let's go ahead and start like slowly moving that code in there. Right, moving that code in there. So this is argv, and we are just temp files, cx unsaved files. If options system include paths, so we have some sort of options. All right. What I'm thinking is that maybe we don't really need any of that. Maybe we can just like use the standard thing. The thing we can do, array add argv to C string, and what we can put in there. You know what? Let's literally grab array lib header and copy paste it here, so we don't have to like go too far away. So array lib, and I'm just gonna copy paste it in here, and we're gonna try to parse that thing specifically. Right, so array lib.h. There we go. So in the module.jai, right, so we do this kind of stuff. We probably don't even need any of that stuff anymore. We probably don't even need. So because now we can just pass this entire stuff, and that is fine. So there's also temporary files, but where do we pass them? So this is we skip that. Okay, so this is done. Ignore. This is argv and argc. Unsaved files, and this one is really interesting. Unsaved files. So do we put anything in there? So we array add. What the hell is that? So I suppose array add, without providing an argument, just adds a new elements to the dynamic array. Is that true? This is kind of a weird syntax. Wait, so it just, this is so fun, right? It like basically puts a new thing in there and returns you that thing, and it returns a point. Seriously, this is how array add works? Really? Wait. This is so fun. Like I didn't know that. So grep array add. Let me see. So let's find some things in there. So basic. It's somewhere in basic. Okay, so let's go to basic. Okay, so here's the version that doesn't accept anything. All right, that's fun. So there is a function in Jai, array add, which basically accepts a pointer to dynamic array and an element that you want to add there. All right, so but if you don't provide any element, it just returns that. Okay, so let's continue. Let's continue. So in the module, right, we just add a temporary file. And what is this temporary file? Contents. This is the contents of the file. This is so weird. Like, what is the temporary files, like temp files? Why do we need them? So it's a CX unsaved file. What is CX unsaved file? Right, so let me try to find that. I have no idea what is that. So it's something from here. So provides the content of a file that has not been yet saved to disk. Each CX file instance provides the name of a file on a system along with the current contents of that file that have not yet been saved to disk. But is that because... All right, so we are... Oh, I see. That is so bizarre. So, you can parse translation unit, and then you can provide a file that doesn't exist on the file system. Okay, this is something interesting to wrap your head around. Parse translation unit accepts command line arguments of clang. It accepts command line arguments of clang, and you can provide the usual things that you can provide in there, for example, file path. But you can provide the files that do not exist on the file system. Right. So imagine being able to do clang, something like WOL, W extra, and then say, oh, main C, but main C does not exist on a file system. And then you have a separate array that associates name main C with an array of bytes, which is the content of that file. Right, so essentially that function will parse the command line arguments just like compiler. It will encounter a name, it will try to find that name on the file system. It couldn't find that file in a file system. It will take your table of these temporary unsaved files, and then it will find, okay, so here is the file, and it will just use the content of that file for that thing. Is that how it works? Is it used for text generated by preprocessor? Probably, I have no idea. That's kind of a weird thing to do like that, but I mean, okay. So in our case, I suppose I just copied the whole thing, right? I copied the whole array lib in there, so I really don't care. And this is exactly what they're doing here. Look at that. So temp file name, here's the name. Then they use string builder to construct the content of the file, right? So they're just building that, and here's the content. And then they're adding temp file name, right? And the content to that temporary file. So essentially, you may not even have a file system, right? So you can just decide, okay, so if you need to find this file, like here is its content, you don't have to go to the file system. This is such a goofy, silly interface. I love it. Like, I'm just trying to think of the use case. Like, why do you need to do it like that, right? Again, as people said, probably from some sort of pre-processing stuff, right? So if you're interfacing with the libclang, you're probably generating a lot of things, right? And you probably don't like want to avoid the file system, right? Because why saving temporary things in the file system if they're already in the memory? Yeah. So it's primarily for temporary things. That's why it's called temporary. Okay. That's cool. Okay, so that's very interesting. That's very insightful as well. I'm not dissing this interface. I'm genuinely trying to understand it. Like what's the use case, right? Like, why would you do it like that? It's very cool. Like it's really interesting. All right. But since we have a file in the file system, we don't really need that. We can just have these stem files in them, right? So main.jib. We can just put them in here, right? And we can just like provide them. So this we just provided a file path. So this is a temp files, right? So the temp files, temp files count. So the only thing that we need in here is the options, right? So let's take a look at these things. So translation unit flags, detailed pre-processing record. So we already provide something in here. So we can say that something is already provided, right? So something is already provided. And translation unit. Okay, so for the translation unit, we provide something which is called translation unit. Okay, and here it is. So I suppose we are allocating it on a stack, and this is going to be the output of this command. This is going to be the output of this entire command. Okay, so we can do that as well. And I suppose we just provided all of the necessary arguments for this function call, didn't we? That was actually easier than I expected, to be fair. That was way easier than I expected. Okay. All right, so we can go ahead and try to build this entire thing and see if it's going to at least build. Right, so let's go. Okay, so let's try to run this entire, and it ran? it didn't crash at least, but we didn't check for the errors, right? So here we getting an error, but we don't do anything with that error, right? Maybe it actually errored out. So we have to do something like this. So okay, so errored out, and in this case, maybe we can have success. We can have success here, and it's initially true. And at the end here, if success is, I don't know, we can just like return like exit one. We don't really need that success. We don't have like a sophisticated control flow with error handling and stuff like that. We have everything very simple. Right, okay. So let's recompile everything and run. Well, first recompile. I want it to be 2 separate steps. Okay, and then run. It didn't fail, what the fuck? It didn't fucking fail. So I think it would be nice to have some sort of indication that everything is okie dokie karaoke, right? So something like this, maybe, so that we can build and just like boom. Okay, it says okay. That's very cool. What if raylib had some sort of like a syntax error in there? For example, load model, right? So let's take a load model and do something nasty. Fucking nasty, like remove semicolon. This is absolutely fucking disgusting, like holy fucking shit. Will that compile or not? It will, so it probably doesn't even work. Anyway, so we're so like happy, alright, hooray, it works! But it works anyway, so just like it doesn't fucking matter. Anyway, maybe we have to explore the internals of this translation unit thing. Right, so let's go ahead and see what we're supposed to do in here. Right, so how do we even use translation unit? Oh, you are supposed to get the diagnostic directly. So you get the diagnostics and then you say, okay, clanks. Okay, all right. So yeah, that makes sense. We can literally yoink that piece of code. There we go. So let me see. So we can try to compile this entire thing and okay, declaration success. In case of a lack of success, I think we can just do exit one. But exit one is kind of dangerous to do because you know, defer is not going to happen. But I mean, we'll see. So the operating system is going to deallocate everything. Clang says, doesn't really say anything, right? So, and it did exit one. So we've got, So I suppose, yeah, it is kind of designed to, like the entire code that we're copy pasting is designed to have this success thingy. So let's just have it, right? So let's just have it. Initially it is true, and if success, we're gonna just do that. Otherwise, exit one. Maybe this is how you're supposed to use that, right? So if success, just do that. Otherwise, like exit with whatever. Might as well, if not, just exit one and then print OK. So that looks even more epic. And you're not supposed to put parentheses in here. So, and then you can do that. How about that? Isn't that poggers? Isn't that poggers? It looks poggers. Okay, so let me see. Boom. std.arg.h is not found. Finally, something that makes sense. And this is probably because we're not like including the system library or something like that, right? So if we go into the thing, so we're supposed to like add system in here. We can hard code some of these things, by the way. We can literally hard code some of that stuff. So if we go to the example and just do j first, first do j, what do we have in here? So here are all of the things, right? All of the arguments. I would like to maybe save them because I think they are useful. I do think so. So we don't really care about the signature anymore, right? So we already, you know, won that boss. And I think some of the these arguments could be useful. I think they could. Array add argv. So let's add system. And I do hard code a lot of stuff right now, right? Because I'm just trying to make something working. As soon as we have something working, we can generalize, we can improve, and stuff like that. So this is something useful. Another useful thing would be probably something like this as well. Array add argv, boom. Right, so let's just have this kind of stuff. And compile. It didn't have any problems whatsoever. If we remove these two things, it should say that it cannot find standard arg, right? Because like it doesn't know the path to the standard library, to the headers of the standard library, stuff like that. But as soon as we give it the path, it is capable of finding them. And it doesn't have any problems at all, surprisingly. Even, oh, we actually removed the nastiest thing. Yes. Yeah, it didn't catch the missing semicolon because I actually reverted that. Let's introduce this nasty, nasty bug one more time. Look at that. We're literally calling clang as a library. That is so cool. Right, and I didn't really have to copy paste too much out of the standard library of Jai. Like I just used whatever like bindings generator provided, and I'm really thankful to the author of the bindings generator for not hiding the internals of Clang. Really, thank you so much, because it's like so easy to use. I can just like import bindings generator and just use the internals of Clang if, like for something else. Thank you. That's actually really cool. Right, I mean, even if you hid the internals, I could have just copy pasted it, but you just like made my work a little bit easier, so I really appreciate that. It's actually kind of cool. So it parses everything correctly, and it fails if it couldn't parse them. All right, so that's literally what we wanted. That's everything we want. Let's dig deeper. Let's dig deeper. So here we do diagnostics and here we check if not success, we're just returning like out of here. Okay, so you're supposed to have some sort of a translation unit cursor. Okay, that's pretty cool. So there's some sort of a, like context, and I don't know what the fuck is this context. All right, context. Where do we get that? Wait. It's a context. It's a Jai context. I know that. It's a Jai context. So we probably don't really care about it then, right? It's just to make things a little bit convenient for the developers of this thing. So the generator global scope members. How do we even use that cursor? Clang. All right, visitor pattern. Ooh boy, Clang visit children. All right, so you're supposed to, okay, handle top level cursors, and we accept the cursor, and within, oh boy, Clang get cursor kind, and depending on the cursor kind, we're just doing different nasty things. Yeah, brother. So create declarations and stuff like that. So we're looking for what we're looking for, actually. I'm not even sure what we're looking for, but yeah. Here comes the fun part of like literally traversing the AST, I suppose, like with the cursor and stuff like that. That's actually fun. Handle top level cursors. Handle top level cursors. Okay, let's go ahead and just like start copy pasting this stuff. So we need to get the cursor. That was interesting. Okay. So this is where we're supposed to actually exit according to that module. Can I just print this entire thing? Cursor, like this. I'm pretty sure it's just like a pointer. Right. So is it gonna do something? Yeah, there we go. So here's the cursor. It's a translation unit, and we have some pointers and whatnot. So all of that makes sense. All of that makes sense. And I suppose the next thing we have to do is this thing. So Clang visit children accepts the data that we pass into the function, right? So handle top level cursor, and it accepts the client data and stuff like that. So that makes sense. So we need this kind of thing, right? So we need this kind of thing. So this is the function that I suppose is going to be called on each top level, right? And top level in the compiler industry, top level is usually called like top level definition or something like that. Right, so we can just do something like top level found, right? Something like this. And also we supply like a client data, and I'm not really sure if we care about the client data. Maybe we do actually, believe it or not, because yeah, we maybe need the context for like memory allocation, for temporary stuff like that. But for now, I'm not gonna care about that, right? I'm not gonna care about that. So the only thing I'm going to do is just like clang visit children, and I'm gonna put null in here. I'm gonna literally ignore this entire thing. Interestingly, I can probably do some stuff in here, like top level found. I can provide the cursor itself and see how many of these things we found. All right. Okay, so semicolon, we forgot a semicolon. What else do we need in here? Not all control flows. Oh, we have to return something. We have to return the CX child visit result. So let's see what we're supposed to return in here. Where is the handle top level cursors? What do we usually return? We can return like continue. Huh, that's very cool. But maybe it's an internal thing in here. I need to find the definition of CX child visit results. So let me quickly do that. Grep rn. So it's an enumeration, and it can be, okay, it can be continue, break, recur. Okay, I see. All right. Since this is like a recursive traversal, the visitor pattern traverses for us, and we return the action that needs to be performed by the recursive traversal. Do we continue? Do we break? Do we recurse and stuff like? Do we go deeper? I suppose. So break. If we return break, it terminates the cursor traversal, right? So that makes sense. So we found what we wanted, and we just say stop, whatever. So continue continues the cursor traversal within the next sibling. So you actually decide whether you want to go deeper or not. So that's very interesting. And then recurse, you mean that you want to go deeper in like recursively and stuff like that. So I suppose in our case, we want to do continue, right? So since we traverse top level definitions, we don't really need to go too deep, right? So in that case, we can just return continue. I think that makes sense. So I'm going to just do continue, just like the module proposes. Right, so what the fuck is going on? All right, so two overloaded functions. Okay, so God damn it. So we shadow definition from bindings generator itself. So it's kind of dangerous to copy paste too much. So let's do the unthinkable. Let's do the unthinkable. Look at it. Look carefully, chat. Look carefully. I'm about to do the biggest sin I've done in my Yes, I want everyone to see that. I'm about to do the biggest sin I've ever done in my entire life. Anyway. So, let's find this thing. Alright, so, and let's review this entire thing. So what else do we have in here? Oh, this one is interesting. Cannot call into a native procedure from Coogle without using push. This is so freaking smart. By using Coogle, you're stripping yourself away from the context, and the compiler actually checks for that. That is so smart, right? So in the context, it's kind of like a, wouldn't say complicated entity of Jai, but in terms of the stuff that you have to deal with, it's kind of similar to this in C++, right? You know, in C++, when you're working with classes, there's this implicit object that is constantly passed into all of the methods, which is this, right? Jai kind of has a similar thing, but it's not on the level of classes. It's on the level of every function, like every function implicitly accepts this context, except if the function is C function, because like, you know, FFI function, right? Because, excuse me, because C functions don't know anything about GI context. And since they don't know anything about GI context, you have to sort of like explicitly work with that. So in here, it is done through the client data, right? So we can probably just copy paste the code for that. Handle top level, right? So the way they do that, they just create it like this, right? And then they just pass GI context, and within the handle top level cursor, they restore the context from the client data to where's the okay, so this is how we do it. So we restore the context and we do the context push, right? So we do the context push, and then they open like a block. Is that a part of the syntax? I'm actually not sure. Probably that's a part of the syntax. Like, are you supposed to have this block? Maybe you're supposed to have this block. We can just do it like that. Hopefully that is going to work. And that is compiles. Okay, so now I'm gonna try. Look, macro definition, macro instantiation, function declarations. We've got them all. Holy fucking shit. We parse C file. We just parse C file. Holy fuck. To be fair, I only care about function declaration. Can we filter them out? Can we somehow filter them out? So here's the cursor, and I need to find the cursor definition. So I'm gonna go there and just like find the cursor definition. So it probably has to be something like a struct. There must be like a counterpart. Yeah, there we go, here it is. So Unix, and you have a kind, and goddamn, I just lost it. Okay, so this is the kind, and we have function declaration. Okay, so let's go there. We have function declaration. If cursor kind is equal to function declaration, only then we're gonna do function found, like so. So I'm using switch case in here so that we can add more things in the future, right? So that's the reason why I do it like that. And now, so let's do it like this, and we should only have function declarations, right? So we only have function declarations. It would be kind of nice to actually see them, right? What's inside of them? Struct. So there's the X data. How do you cast it to different kinds of things? Right, so let me see. So kind, okay, so we do, oh, you're supposed to get the kind through clang get cursor kind. But I mean, I can access it directly, like it's not that big of a deal. Okay, fine, you won. I can do it like that. So I'm gonna go to main, and I'm gonna just do clang get cursor kind. What was that? Yeah, cursor kind. Why don't you just autocomplete what I want? Yeah, there we go. We can just do it like that. And there we go. So, how do we handle the kind? How do we handle the kind? Link special. So I just want to see how we, yeah, okay, so here's the macro definition, and then we can get its name. Oh, you create declaration. So we create declaration for something. This is not what we want. This is not what we want. I want to see a way to cast the cursor to something else. Clang. So we get cursor kind. So maybe there's something like function declaration. Right, so I know that the cursor is function declaration, but how do I go further? How do I get the function name, for instance, or function location and stuff like that? Sec cursor. I do have the kind and x data and data, but like, how do I go further? Clang cursor is null, is reference, is attribute. So get, maybe you literally have to use one of these functions, right? Clang, get cursor. Yeah, maybe you have to do get cursor name or whatnot. Clang get cursor name, get cursor kind, get cursor reference, get cursor visibility, get cursor availability, platform support, and so on and so forth. So what's funny is that we may not even have everything in here, right? Maybe it only has the bindings that are necessary for the binding generator to work. Maybe you need to step into the function declaration. No, I don't think so. Maybe I do. Probably. I don't freaking know. So let me just look. So cursor, log error. So function decl. Okay, so there is this one funny things. So this is an interesting function we have in here. What is this function? This is a create type. It accepts the cursor, right? It accepts the cursor and the type and stuff like that, and looks for different things, and creates the type out of that. So let's find the cur kind. Our cursor, our kind, parameter declaration. So we get the children, if it kind type def. Function declaration fall through. Get children, for the children type reference, type index. We never cast the cursor to anything. We never cast it to anything to get some additional information out of that. Get cursor referenced. So maybe we can find some stuff in here. So Clang, this is the C interface. Get cursor. It's not there. Let's literally search for Clang get cursor kind, and maybe somewhere there. So cursor manipulators. Okay. What else do we have in here? Is preprocessed, get cursor availability. And this is the cursor kind. Okay, so maybe we can read about that. Cursor represented some elements in the abstract syntax tree for translation unit. The cursor abstraction unifies the different kinds of entities in a program declaration, statements, blah blah blah, under a single cursor abstraction with a common set of operations. Common operations for cursor include getting the physical location in a source file. Okay, can be produced in specific ways. All right. Can I get the location at least? Doesn't tell me. It really doesn't tell me. I want to get some sort of information. File? Included file. Oh boy, oh boy, oh boy, oh boy. So Clang C index location. C, okay, so there is a C. It's literally called get C, Clang get CX location. Okay, so we have to provide translation. Well, so it also file. So source location. Maybe there's some things in here that also get the file and the cursor. clan get cursor location. All right. So we can literally do that. Okay, so finally, at least something. So difficult to find anything. Jesus fucking Christ, mate. So we can do cursor, we can do location, and can we just like take a look at the location of this stuff? Ooh boy. Clank, am I right? Freaking clank. Now we're freaking talking. Okay. So, and what is a CX source location? CX source location. CX source location. So where it is. So it's very abstract though. Like it's 2 pointers and something like that. So clank get file. Okay. So you holy shit. Okay. So you have to go even further, right? You do get file location. You have to provide the pointer to CX file and line, column, and of. Okay, I see how it works. I see how it works. I think we can do that. So now, right, we can just provide it like that. We provide the location. I need to have CX file, right? So this is a CX file. Then unsigned line. Do we already use this function in this module? We don't. It's not used there. Okay. So we have to provide the pointer to the file, the pointer to the line, and some other things. So when we need to put unsigned, how do we even do that? What kind of type do we use? What kind of type do we use? Do we use integer, unsigned, uint? So the question is, what type do I use? Do I just use okay, u32. Thank you so much, chat. Yeah. Thank you. So we need to have line, column, and offset. I wonder if I can just, combine all of them together like so. I think I should be able to. And column. I'm not sure if offset is very useful, but we'll see. So CX file, that is a very interesting thing. So what is a CX file? So there is a CX file in here. CX file, so what is it? A particular source file, okay. You have to get a file name out of that in a CX string. Are you freaking serious? Okay. I mean, can you just give me the freaking string already? Okay. S string, file string, and on top of that, I have to extract this thing out. Is it okay? There is a header. Clank people. What the fuck is? Why do you? Calm down. Everything's fine. Finally. But that actually begs the question, like, is it just a pointer, not terminated? A character string. Type is used to return strings from the interface when ownership of the string might differ from the ones to call. Clank get C string to retrieve the... And you have to not forget to dispose it because all of that shit, of course, it allocates memory. Holy shit. Oh my god. This is so dense. Oh my god. File string. But it's only a C string. That's the thing. That's a C string. Now we now have to convert C string to J string, which is sized. How do we do that? I have no idea. All right, so C string, clank. Okay, so all right. You have to use toString. I see. So, the bindings generator creators also had to deal with this kind of bullshit. Yes, we even copy pasted this code. Like, yeah, I just copy pasted the code, but they never looked into it. But it actually contained the this bullshit, right? So, Jesus Christ. So here is the string, and then we have to do toString. So the thing I want to do something like this. Function declaration. So we provide C string, toString like so. Then we provide the line and we provide the column. And we have to also clang dispose. Dispose string, what was that? Yeah, dispose string. And it has to be the string that we got from there. So this is a struct. So I suppose we have to do file string, not C string, but file string. Okay, so that's what we do. Oh my god. Okay, so now we should be able to. Okay, here are all of the function declarations. Here are all of the function declarations. Ooh, oh boy, so that's very cool. We don't really know the name of this stuff though. Right, so CX source location, but it's just like CS cursor. Does it have cursor stuff? So I think it's index. Name. So when I want to find the name, how do I find the name? So you can get the file. So for the cursor, maybe there is something like get name type, module get name, right? Let's do grep, also case insensitive get name, module get name. You can't really get name of the function, but I'm pretty sure this thing is capable of getting the name. Function declaration. We should see the type. Yeah, it doesn't help. Get translation unit. Something maybe name. Lib names. Reserved names. Symbol names. Though reserved names. This is Jai reserved names. Type defs to unwrap. So we somewhere compare the names with these things. Right. So we just do that. Should unwrap type def array find. Okay. So where do we get the name? Where do we get name? Holy fucking. Okay, get name for the cursor. All right, so we're getting deeper. Where is the get cursor spelling? You mother. Why? Why would you call the function like that? Are you insane or something? What? Retrieve a name for the entity reference for this cursor. A name for an entity for the cursor is spelling. Spelling. I'm gonna go fucking insane. Like, okay. So, all right. Sure. I'm having like a cultural shock right now. Like, it's just like I'm really shocked. Okay. Sure. So we got the name, the location and stuff like that. So let's try to get the name, right? So here's the name. So this is the fucking spelling. Of course, Zozin, didn't you know that it's fucking spelling? And now you also have to convert this entire thing to the C string, because that's not enough, right? So so C string name. As far as I can understand, like, you don't really have to have this intermediate thing, so you can kind of inline. So that's totally fine. Right, so we have a name strings, and we should not forget to dispose the name. So and in here we can just put something like this: name string. Can you see Scheiße? Okay, so now you can see the clang. Get C string, get C string and toString, like so. And why did I put S in here? It's just like silly goofy Scheiße. Yep, we got the names. Spelling. Fucking spelling. I swear to God, meine Freunde. Oh boy. All right. So I think we're like, yeah, that's a good start. Right. So at least we're capable of now parsing like basically any header and stuff like that, and just like extracting that information to some extent. It's a little bit painful. It's a little bit weird, but we can at least get the names and locations and stuff like that. If we dig a little bit deeper, we can probably even find some you know, so some signature types like return types, the argument types, and that's everything we need to build some sort of a database, and then we can search within that database. So I can see that this entire thing is feasible with at least libclang. Right, so yeah, what's cool is that libclang has like a C interface, so that means I can do pretty much the same thing in other languages. I can like do this thing in C directly if I want to, though with Jai it's a little bit easier, right? So it's definitely easier because it like the bindings generator just provides everything we need, right? So I think that's a good ending for today's stream. We achieved something, right? We explored different things. We tried Python, we tried TCC, and we tried Jai, and it actually provided, right? So Jai won yet again. So yeah, I guess that's gonna be it for today's stream. Thanks everyone who's watching right now. I hope it was interesting. Have a good one, and I see you all on the next recreational programming session with Azuzin. I love you all. Mwah.